Hello everyone, this is Sangeeta, Assistant Professor, ECE Department, SNS College of Technology. So in this video, we are going to discuss about the up-down counter. That is, it comes under the sequential circuits. So in this video, we are going to cover what is meant by counter and what are the needs of using up-down counter and circuit diagram and state diagram and applications of up-down counter. So before that, let us have a small recap about the previous session. So in the previous session, we discussed flip-flop and different types of flip-flops. So first we should know what is flip-flop, because in this video the counters are made up of flip-flops. So a flip-flop is a memory element that is mainly used to store one bit of information. So there are different types of flip-flops. D flip-flop, that is delay flip-flop, toggle flip-flop, that is D flip-flop, JK flip-flop, SR flip-flop. And let us move on to the topic up-down counter. So this video is based on the design thinking. So the design thinking is a human-centric approach which is used to collect, which is used to think beyond the out of box. That is, it is mainly used to design the product or design the project based upon the user requirement. So first the step is empathize. That is why we need the counter. So the counters are mainly used to count the events, and also it is used to generate timing signals and control process. That is, in real-time application it required to control the total process, and the directions can be stored for counting process. So these are the empathy points that why we need the counters. And based on the empathy points, we can define what is a counter. A counter is a bidirectional counter, that is up-down counter is a bidirectional counter that it can count in both the upwards and downwards. Otherwise, we can say it the up-down counter used to count in ascending order and also in descending order. So the counter, up-down counter counts in both the direction using the control signal, and it can be synchronous and asynchronous. It is available in the form of IC. The IC number is 74193. And ideas, that is, while we designing the up-down counter, there are some steps to be followed. The first step is we have to define the sequence, and after that the number of flip-flops. So suppose if our sequence is 0 to 9, we have to select the number of flip-flops based on the counting sequence, and after that the counting, that is state diagram, has to be drawn, and the number of flip-flops has to be chosen, and the excitation of the particular flip-flop has to be written. After that, the last step is minimize the expression. Here I have listed the excitation table and state diagram. This is the state diagram. This is the state diagram, and in this the sequence starts from 0002 to 111, and here that is this is the excitation table, that is here M and Q3, Q2, Q1, and again Q3, Q2, Q1, and T3, T2, T1. That is the T1, T2, T3 or the T flip-flop sequence, and Q1, Q2, Q3 are the output of each flip-flop, and M is the control signal. If the control signal is 0, it counts in the upward direction, and if the control signal is 1, that is m is equal to 1, it is in the descending order, that is downward sequence. The arrow marks, okay, if m is equal to 0, the counting starts from 0, to 1, 0, 0, and 0, 1, 1. So next, if the control value is 1, that is m is equal to 1, 1, that is in the reverse direction. And this is the circuit diagram for up down counter. Here we use 3 flip-flops, that is T flip-flop, and there are 3 flip-flops. So T flip-flop is a toggle flip-flop. So T flip-flop is 0, it holds its previous state, and if it is 1, it is toggle, that is called it as T flip-flop. Here there are 3 T flip-flops are used, and M is the control signal, and for M bar, that is for making M is equal to 0, we are using inverter. So the logic 1 is given to toggle the flip-flop, and clock signal, this is the clock signal. So this is the circuit diagram for up-down counter. And the ideate for this, it may be synchronous or asynchronous. That is, synchronous means all the flip-flops which is connected in the circuit are triggered simultaneously by a common clock. And asynchronous means the output of one flip-flop triggers the next flip-flop. And also it is a presettable, that is, it can be initiated to any starting value. So the IC number already we discussed 74193. And the main applications are motor position control, digital clocks, frequency measurement, elevate floor controls. These are the main applications, and it can be designed using JK flip-flops also. And this is the circuit diagram, and here the single clock is used, and it can be designed using JK flip-flop also. The main advantages of up-down counter is bidirectional control, flexibility, IC availability, and dynamic applications. And there are some limitations, that is increased complexity, high power consumption, and design challenges. These are the some real world application. And hope this video will help you to understand what is meant by counter, and what is up down counter, and how it can be designed, and what are the main applications. Here is the assessment time. So first question is, what is the primary advantage of up-down counter over a unidirectional counter? So the main advantage is flexibility and direction control. And the second question is, describe one real world application. So there are digital clock is one of the application, motor control is one of the main application. And the third question is, how does the control signal affect the operation? That is the mode control pin M. If it is 0, the counter counts in upward direction, and if it is 1, the counter counts in the downward direction. These are some references for up-down counter. Thank you.